All right, section 5.6, the quadratic formula. It's our first day on this fancy topic. All right, so we are going to solve quadratic equations using the quadratic formula, and then we're going to classify the roots using the discriminant. So what is the quadratic formula? Okay, so given you have a quadratic, all right, then the solutions of it, or the roots, are using the quadratic formula, x equals negative, or what they call opposite of b, plus or minus the square root b squared minus 4ac all over 2 times a. Right? Your a, b, and c are the order of our coefficients and constants in our standard form equation. Okay? So let's use it. So we're going to find the zeros of f of x equals x squared plus 3x minus 7 using the quadratic formula. A lot of you, this is going to be your favorite way of solving anything because it's very cut and dry. Okay? So make sure your function's in standard form and set it equal to 0. So in doing that, I get x squared plus 3x minus 7 equals 0. Step 2, write the quadratic formula. The more you write it, the easier it is you're going to remember it. And yes, I would like you to know it. All right? So opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Very important. Put stars around it. Remember it. Step 3, substituting the values for a, b, and c. So in this case, a is 1, b is 3, and c is negative 7. So you're going to plug in all those values. All right? From there, you're going to simplify it. So this is just negative 3. 3 squared, 9. Negative 4 times 1 is negative 4, times negative 7 is positive 28, and 2 times 1 is 2. All right, so that's what I have when I simplify it the first time around. Now finish simplifying it out. The only thing I can do yet from here is add the 9 and the 8. 9 and the 8 is 37. My final answer, x equals negative 3 plus or minus the square root of 37, all divided by 2. All right? So substitute in and simplify. Order of operations. Okay? So let's look at another. We're going to do 2 more examples because the way we deal with the answers at the end are going to be a little bit different. Same process, okay? So step 1, make sure it's in standard form and then set it equal to 0. So my function is x squared minus 8x plus 10 equals 0. Step 2, write the quadratic formula. Okay? So the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Write it down, use it. Substitute in the values for a, b, and c. A is 1, b is negative 8, c is 10. Simplify it. Simplify it. Negative times negative 8, this is going to be positive 8. Negative 8 squared, positive 64. Negative 4 times 1 is negative 4, times 10 is negative 40. 2 times 1 is 2. So that's my first step of simplification. Simplifying. All right, do the math inside. 64 minus 40 gives me the square root of 24 under that. Square root of 24 has perfect square in it. Okay? So when I simplify that down, it's 4 times 6. Square root of 4 times square root of 6. Square root of 4 is 2. All right, that's where the 2 comes from. So 2 squared is 6. Last step, keep simplifying. Not quite done yet. Why not? Every part of this, so the 8, the 2 square roots of 6, and the denominator all have a 2 in them. All right? So this 2 cancels with this 2, cancels with the 2 in here. So you're left with 4 plus or minus the square root of 6. Okay? When you're simplifying, only worry about the number out in front with the square root of 6. All right? Don't worry about the square root of 6. You can't simplify that since the 2 on the denominator does not have a square root. All right, let's look at another one. Same process. Same process before, just the ending's going to be a little bit different. So find the zeros of 3x squared minus x plus 8 using the quadratic formula yet again. Make sure the function is in standard form. Then set it equal to 0. So I have 3x squared minus x plus 8 equals 0. Write the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. plug in the values for a, b, and c. A is 3, b is -1, c is 8. Okay? Then we need to simplify. Negative times -1, positive 1. -1 squared, positive 1. -4 times 3 is -12. -12 times 8 is -96. 2 times 3 is 6. So when you do that math and you simplify it out, that's what it looks like. So now we need to finish simplifying from here. 1 minus 96 is square root of -95. Okay? Now this starts coming in with the imaginary numbers. Factor out your square root of 95 and your square root of -1. Okay? So you're left with the square root of 95 and then I. Alright? The only other thing I did here is I separated these, so I gave the 1 its own denominator, square root of 95, because the I only goes with this part, not the whole thing. That's why I separated it. Okay? Alright, so use those examples, all 3 of them, use the steps. Do the now you try. Okay? The next part is dealing with the discriminant. Okay? So you have your quadratic formula. This yellow part is the discriminant. So from your definitions, it's part of the quadratic formula that you can use to determine the number of real roots of the quadratic equation. In doing that, okay, when you plug in the values and do the math for the discriminant part, the part underneath the square root, okay, if you do the math and the value is greater than 0, you have 2 real solutions, 2 distinct real solutions, so 2 different real answers. Okay? If you plug in the values and it equals 0, you have 1 distinct real solution. So you'll get 3 over 2 twice because you only have 1, 3 over 2. And then the last option is if you do the math and the number is less than 0, you have 2 distinct non-real complex solutions. So it's going to be 2 values, 2 answers that have I in them. Okay? So similar to the quadratic formula, now we're just going to plug in the values from each of our equations. All right? So that we want to find the type and the number of solutions for each of these equations. All right? So step 1, write the equation in standard form. So it's going to get x squared minus 4x plus 8 equals 0. Now you want to write out the equation to determine the discriminant. Okay? So it is the part from under the square root. So b squared minus 4ac. Substitute in the values of a, b, and c. A is 1, b is -4, c is 8. Simplify it from here. Okay? So -4 squared is 16. -4 times 1 is -4. Times 8 is -32. Alright, so 16 minus 32 is -16. Right? The value is less than 0. So identify the number and the types of solutions. So if it's less than 0, I have 2 solutions, 2 distinct solutions, and I know that they are non-real complex solutions. Okay? So that's all you're doing. You're just identifying how many and what type they are. You don't have to go through and find them. Okay? So let's look at another one. Same exact setup, same step, different example. So x squared plus 30 equals 12x. Write the equation in standard form. I have to move the 12x over, so subtract it from both sides. X squared minus 12x plus 30 equals 0. Write my equation that helps me to determine the discriminant. So b squared minus 4ac. Substitute in the values for a, b, and c. A is 1, b is -12, c is 30. Right? From there, you just need to simplify your values. -12 squared is 144. -4 times 1 is -4. Times 30 is -120. Okay? So do the math. 144 minus 120 equals 24. 24 is greater than 0. So using that value, 24 greater than 0, I know that I have 2 distinct solutions, and I know that they're both real. They're real solutions, no imaginary numbers. So there you have it. Now you try. Find the type and the number of solutions for each equation. So type it out. Use the steps and the examples. Adios, amigos.